All right, we're going to talk about Theorem 2, the sandwich theorem for sequences. Now, this is the same sandwich theorem that we learned about back in Chapter 2 when we were learning about limits, except that now we're going to apply it to sequences, or we're going to apply it to the nth term of a sequence. So I'm going to read through this, but there's an awful lot of information, and we're going to have to unpack it. So the theorem reads, if the limit as n goes to infinity of an is equal to the limit as n goes to infinity of Cn, and both of those limits are equal to the same thing, L. And if there's some integer n for which the terms of an are less than or equal to the terms of bn, which are less than or equal to the terms of Cn, for all little n greater than big N, then the limit as n goes to infinity of bn is equal to L. That's a lot. So let's kind of unpack this. So first of all, we're talking about 3 different sequences. So we've got sequence AN, BN, and CN. And we have some information about AN and CN, and that's what's up here. We happen to know what their limits are. We know that those sequences converge. So if we draw a graph over here, and I'm going to have AN do something like that. And we're going to switch colors, and we're going to make CN do something like that. And if we go out to far enough values of N, then we know that AN and CN are going to converge to some limit L. And you can kind of see that from the graph, that they're both approaching that same value of n. Well, we have to know something very specific now about Bn. And that says that if we go out to some, this is going to be our little n-axis, if we go out to some value of big N, so there's some index, and as long as we let our index be bigger than this n, then Bn is going to be sandwiched between An and Cn. So I don't really care what Bn does, except that once it passes this n value, it's got to stay in between An and Cn. And if that happens, if each term of Bn is greater than or equal to An and less than or equal to Cn, after this line here that goes with this capital N, then the limit of Bn has to be that L, because it's going to actually be squished between the line for Cn and the line for An. And that's what the sandwich theorem is trying to tell us. Now, the tricky part is if you have an expression for An, figuring out an expression for something that's going to be smaller than every term and something that's going to be bigger than every term if we go out to large values of n. And we will do a couple of examples about that.